Welcome to the TechHub.training Managerial Margin Maximization Challenge solution. In this challenge, we were looking at some data from a company and trying to help them optimize their product mix to maximize revenue. So let's go ahead and jump into the data, looking at Excel first. Alright, so here we have our Excel file, and what I've done here is taken this original data and created some formulas in some of these cells to get us to our first point. So contribution margin we use by calculating revenue minus all the variable costs, and so we do that for both products A and B. And then to calculate total profit per product, we have the contribution margin times the number of units sold less the allocated fixed costs. And so for each of the units, you can see there about $140,000 of profit, getting us to $284,000 of total profits. The next thing we did was use the solver tool. And so, looking at our data, we can jump into the data and the solver to use that tool. But the first thing we're going to want to do is create those last few formulas. So we're going to create the floor space percentage, because that's how we want to reallocate our fixed costs, and reallocate the fixed costs based on that. So we have the total fixed costs times the floor space percentage, and that's how we'll get to the reallocated fixed costs there. And then this optimal unit solved and optimal mix we'll solve for using solver, and the profit will update. And I also created these columns to help me check and make sure everything looked okay, and also I used this cell in the solver. So let's go ahead and take a look at what that actually looks like. So in my solver, we're going to look at cell E16, which we have here, this total profit, and we're going to want to maximize that by changing these number of units sold. By changing these as the number of units sold. And our constraints here is we can't produce more than our production capacity of either product. So this number has to be less than or equal to this. Same with this number here and this number for those products. And finally, we only have a certain amount of direct materials we can use between both of these products. So we're going to make sure that this number, the sum of direct material used, is less than or equal to the maximum number of direct materials. And then when we solve this, we're looking at a $316,000 total profit. And the reason I broke this out into two sheets is so we can look back and look at our old data to see the change over time, which we'll use in our visualization. And kind of along similar lines, I created a copy of this, called it import solution, because that's what I'll import to Power BI. And that's, again, if we want to go back and make changes in the solver, so we have a history of our work, because the solver will just write over things. So the next thing we're going to do is load this into Power BI. So I'm going to close this out so Power BI can access it. Alright, so here's what the visual looks like ultimately, but first let's take a look at the data in Power Query. So if we open up this transform data, this will show us the steps we took using Power Query. So if we jump into the beginning where we imported it, you notice we got a lot of null values, and we got columns here that don't necessarily align with one another. And what we want ultimately is to have a row for product A and a row for product B with the relevant information laid out like that, so we can transform it and make visualizations from it in Power BI like we want to. So the first thing we're going to do to make that happen is promote the headers. So the first row, instead of being product AB as the first data row, we promote that, so those are the headers. Next thing we're going to do is remove some of those blank rows, and then we're going to pivot the table to get A and B on the rows side of things. So we're going to demote the headers again, pivot the table there, and then re-promote those other headers, and then remove the bottom two rows, which are null in almost every case. And this way we still have some data that's empty, but we have the core data. And the reason a lot of this is empty is because this is our original data and it doesn't have those highlighted cells filled in yet. So let's take a look at our post-solver solution now. Again, kind of the same deal with null rows and whatnot. So let's take a look at what we did there. Remove some of the blank rows and then transpose the table, so getting product A and B on the left side, promoting those headers, and then making sure everything is the appropriate type. So instead of these being alphanumeric fields, just making them numeric. C goes to 1, 2, 3. And then again removing those last two rows of null data. So then if we take a look at our visualizations coming out from that, what I have here is I created a card showing the original profit from that original table, and then the optimized profit coming from that import solution table that we did post solver solution. And then I created some graphs to help visualize that. So here is the current or original quarterly sales and profits. So you've got number of units sold and then the sum of the profit for each of those. As we can see, remember, it's around 144,000 for each of those. And then when we optimize it, we're selling as much of product A as possible and just using the remainder to sell product B. So the product for A goes way up. It looks like we're selling less comparatively, but that's just because it's on the same scale as this profit. So the profit's over $500,000 and the units is up to 35,000. But another good way to compare this is using this slicer. So if we go over here and select product A, then we can compare them easily to one another. Originally we were making $140,000 on product A, but post optimization we're making $526,000 of profit off product A with this almost $400,000 increase. Similarly, if we look at product B, originally we're making $144,000, but optimally we're producing as much as A as possible, and so we end up losing $210,000 on product B, leading to a negative $354,000 swing in this product. And this data can be valuable because then we can go to management of the company and say, hey, look, we know you're making more money with product B right now, but if you actually sort of optimize your costs and your product mix, then we recommend taking some maybe drastic measures, maybe even entirely cutting out product B if we can't find a way to make that profitable. And so that's one way that these data visualizations can be really powerful from a management and consulting perspective. So I hope you enjoyed this challenge. This was a lot of fun, I think, using the solver function in Excel as well as the visualization function in Power BI to really take advantage of some of the more powerful features of each of those programs and getting our toes with some Power Query if you're new to that. So let us know what you thought of the challenge. Be sure to post your solution on TechHub.training website, and we'll see you next time.